All right, today we are going to continue with lesson 4. It'll be the back side of our translating algebraic expressions and equations notes from yesterday. We're going to be doing one-step equations and two-step equations. I am going to explain how I expect everyone to show their work during this first semester. When we get to Math 1 next semester, you won't be required to show the same amount of detailed work just for the first semester. All right? And I do understand that you all are smart enough to look at example number 1 and say, what plus 12 equals 10? I know that you can do that in your head. However, I do expect everyone to show their work properly, even with these one-step equations, so that when we get to our second unit and the equations are much bigger, for example, 2x plus 3 times the sum of x and 9 equals 3/2 x minus 2/3. Something like that is going to require a lot more work to show properly, and it's going to get easy to get lost or confused in the process. So we are going to learn how to show our work properly now. So let me erase this example, and then we're going to start off then with our one-step equations. The first thing that I require of you is that every student draws a rose line. I call it a rose line because I always do it in red. I've heard other teachers refer to this as the river as well. If you do it in blue, it's still just the same thing though. It is drawing a line that goes directly through the equal sign to divide your equations into the left and the right sides. All right? If at any point we ever cross that line with a number or a variable, we will need to do an inverse operation. And that's going to be our second step, inverse operations. Okay. The inverse operations are the same as what we discussed when we went over our properties of integers. So if I am adding, the inverse operation of that is subtraction. Or if I have subtraction, the inverse would be addition. Also, if I have multiplication, the inverse of multiplication is division. And then it does go from division, the inverse would be multiplication. And then one last one that we will sometimes use is the inverse of a square root is going to be a square. Okay, a number squared. And then the inverse of a number squared will be taking the square root of that. I don't believe that we're going to see an example of that in our notes today, but I will go ahead and add one so that you can see what that would look like. All right, so starting with example number 1, and I've already drawn my rose line, I am going to start by focusing on where the variable term is in the equation. In this case, the variable term is on the left. So the numbers that I want to focus on moving are going to be the numbers that are already on the left. And when I move them, I'm going to want to move them to the opposite side of the rose line. So I have m plus 12. The inverse of plus 12 is subtracting 12. And whatever you do to the one side, you have to do to both sides. So, show that you're subtracting 12 from both sides. Draw your line. Positive 12 and negative 12 will cancel. I bring down the m. I bring down the equal sign. And then I do my integer operation here on the right side, which is 10 minus 12. And that is a negative 2. And I want to circle my answer so that I know that that is the final answer. I don't think that was so bad. And again, most of you could have done that in your head. we are practicing how to show the proper work here. Let's look at example number 2. I'm going to identify where is the variable term, and in this case it's on the right-hand side. I am going to do the inverse operation of the number next to the variable g. The inverse of subtracting 9 is adding 9, and I'm going to do that to both sides. Negative 9 and positive 9 are inverses, so they cancel. Bring down my variable, bring down the equal sign, and then I'm going to do my integer operation. Negative 2 plus 9 is positive 7. Now, it is important that you use the reflexive property here to write your final answer. Remember, the reflexive property says if 7 equals g, then I can also say that g equals 7, and I can flip it around, and that's going to be my final answer. And that is the reflexive property. All right. Example number 3. I have negative 7y equals negative 91. The operation here with this y is actually multiplication because there's no operation showing in between the number and the variable, and we know by now that that represents multiplication. So the inverse of multiplying by negative 7 is dividing by negative 7. Negative 7 divided by negative 7 is 1. So I bring down my y, 1y, bring down the equal, and then I'm going to do my division. Negative 91 divided by negative 7 is 13. And that's my final answer. Let's look at number 4. I have a divided by 9 equals negative 4. So my variable a is right here. The inverse of a divided by 9 is going to be multiplying by 9. So I will multiply both sides by 9. And I'm going to keep the sign here the same. Again, I'm doing the inverse operation. I'm not necessarily just changing the sign. I'm changing the operation. 9 divided by 9 is 1. Bring down the a. Bring down the equals. And then do the operation over here on the right side. Negative 4 times 9 is negative 36. And circle that final answer. Hopefully we all remember one-step equations fairly well, but let's step it up. So we're going to go and add fractions to the mix. All right? When we have one-step equations that have fractions, we want to get rid of the fraction by multiplying it, both sides of the equation, by the reciprocal. Reciprocal is kind of a funny word to spell. The reciprocal of a fraction is, let's see, if I had 1/5, the reciprocal of 1/5, I'd have to flip it upside down, would be 5/1. All right, so it's just flipping your fraction upside down. So I'm still going to draw my rose line for every one of my examples here. And then I'm going to look at number 5. 2/3 times x equals 10. Now I am going to show some additional work up here, okay? Whenever we had multiplication, we said the inverse of that was division. So 2/3 divided by 2/3 And I just want to explain why we're multiplying by the reciprocal rather than dividing by the number. If I did 2/3 divided by 2/3, you might have learned back when you were learning how to divide fractions that we keep the first one, we change division to multiplication, and then we flip the second fraction. So that would actually look like 2/3 times 3/2. So I am ultimately going to have to multiply by the reciprocal. So I just cut out that middle work for you, and I'm just teaching you that we're going to multiply by the reciprocal. But this is why we're doing that, all right? So let's do that to both sides. I'm going to multiply both sides here by 3/2. Okay. And I forgot to circle my variable there. All right, when it comes to simplifying this, 3 divided by 3 cancels, and it gives you 1. 2 divided by 2 cancels, and when I say cancel, I really mean reduces. Gives you 1 also. So I'm left with 1x. Now I'm going to do the other side. I've said in class, whenever you have fractions, just make all your numbers fractions to make it easier for you. And with fractions, when we're multiplying, we do multiply straight across the top and straight across the bottom. So 10 times 3 is 30. 1 times 2 is 2. And for my final answer, I'm going to reduce that if possible. So 30 divided by 2 is 15. So in this case, my answer is x equals 15. Hopefully you were able to follow along pretty well with that. Just in case, we are going to do a couple more examples, all right? Number 6, 4/9 times the variable w is equal to -8. So I drew my rows line, I circled my variable. Now I am going to multiply both sides by the reciprocal of this fraction. So 9/4 and 9/4. All this will reduce to 1. Make this a fraction, multiply straight across, top and bottom. -8 times -9. Anybody know what that is? Think for yourself for a second. Is it going to be positive or negative? Okay, 2 negatives do give me a positive. It'll be 72. 1 times 4 is 4. So I have 72/4. And then I just need to reduce that fraction. So I'm going to get w equals 72 divided by 4 is 18. But if you don't have a calculator to do that, just a reminder of this long division. Oops, that should be a 2. 4 goes into 7 one time. 4 times 1 is 4. I have 3 remaining. Bring down the 2. 4 goes into 32 8 times. So it is 18. All right. I want you to pause the video and try number 7 on your own. When you come back, I will show you my work for number 7. All right, welcome back. I do want you to look at number 6 for just a second. I made a mistake when I drew that green line connecting the -8 to the 9. I interpreted that as a negative on accident when I did my multiplication. So it should have been a -8 times a +9, which would make that 72 a negative, which also means that when I divided -72 by 4, my final answer should have been a -18 there. I just wanted to go back and correct that so your notes were not wrong. All right, now look at number 7. Some of you very possibly made the mistake of multiplying both sides by only 5/6. Remember that we're doing the inverse operation. We're not changing the sign here when we do multiplication. So I should have multiplied both sides by -5/6. When I did that, I multiplied straight across 12 times -5, and I got -60. 1 times 6 in my denominator gave me a 6. And then reducing it. Some of us still struggle with reducing fractions. I just found a number that they could both divide by evenly. In this case, it was 6. 6 divided by 6 in my denominator gave me a 1. So -60 divided by 6 was a -10. And that's my final answer. I did not have to leave that -10 over a 1. All right, let's do number 8. Multiply both sides by the number with your variable there. So I'm going to multiply both sides by -2/1. -2/1. So m will equal, and if you like to show your work kind of how I did here in number 7, you can do that. Okay, -9 times -2 is a +18. 1 times 1 is 1. And so I just bring my final answer right there. All right, and then I did promise you that I was going to show you one example of how x squared would work. So an extra example is x squared equals 4. And we're really going to get into this more so when we are in Math 1, but I just want to show it to you as a preview, all right? So I have x squared equals 4. Here's my rows line. The inverse operation of x squared is taking the square root. So the square root of both sides. The square and the square root here cancel, and my x is now by itself. And then I just need to simplify. What is the square root of 4? The square root of 4 is 2. So just a little preview for you, and if you see one of those in your homework or in any practice problems, then you will know how to handle that. But it is still just a one-step equation. All right, so I feel like we're pretty good with one-step equations. Let's go look at two-step equations. In two-step equations, they're called that because they're going to have 2 steps, but I still want you to, every time, draw the rows line. And I have already done that for us. All right? Next, we will start by always doing addition or subtraction with our constant term. Remember, the constant term is the number that's all by itself. After we do that, we will use multiplication or division to move the coefficient. The coefficient is the number in front of the variable or attached to the variable, all right? So I'm going to circle my variable terms in green this time. And then to identify my constant term, the constant term is going to be the number that's being added or subtracted on the same side as the variable. So I see here this +8. The inverse of +8 is -8. And I'm going to do that to both sides. That will cancel. Bring down your 6x. Bring down the equal. And then do 50 minus 8, which is 42. Okay. Next, I see 6 times x. I'm still focusing on the side with the variable. So the opposite or inverse of 6 times will be dividing by 6. 6 divided by 6 will cancel. X will equal 7. 42 divided by 6 is 7. Okay, I'd like for you to pause the video and try number 10 on your own, and then check back with me in just a minute and we'll see how you did. All right, take a look at number 10. Follow through. I've color-coded my steps, and just make sure that you showed your work properly. I don't want you doing all of the thinking in your head. I do need to be able to see your thought process on paper. If your notes are completed and you got to the correct answer on your own and you feel pretty confident, I want you to go ahead and complete numbers 11 and 12. If you were not able to get number 10 on your own, I want you to pause the video, ask Miss Brown to come look at the work that you did show on your paper so that I can try to help you find where your mistake might be. For those of you ready to move on, go ahead and do 11 and 12 and then check back with my answers in just a second. All right, hopefully you were able to get both 11 and 12. I do want to point out that in number 11, my variable term was on the right-hand side of the equation all the way through the solving process. And at the very end, I used the reflexive property to flip it around so that my variable term was on the left. It is good practice to get used to doing that now, just so that when we get to inequalities, when the variable is required to always be on the left, that we're used to doing that already. And some of you might even like to do the reflexive property before you begin a problem. So if you would like to see how that looks, I could start with the original problem. 13 equals negative 4k plus 9. And I could just use the reflexive property straight away and rewrite that as negative 4k plus 9 equals 13. And then you don't have to worry about doing it at the end. However you're comfortable doing it is fine with me, so long as you just draw that rose line and show all of your work. All right? I'd like for you to go ahead and move over to number 13 with me. And let's see how it looks when we include division into the mix, okay? So I've drawn my rose lines. I'm going to circle my variable term here. All right, well, I'm not able to circle my variable term because it's too close to the top of my screen. However, I can still do the process the same. So I'm going to go ahead and I see this minus 7 is the furthest away from the x, but on that same side of the equation. Okay, so I'm going to start out by, adding 7 to both sides. Those cancel. I have x divided by 2 equals, and 9 plus 7 is 16. And now what I have is x divided by 2. Now I can circle it. It's a little lower. X divided by 2. And the inverse of dividing by 2 is multiplying by 2. And if you want to put it over 1, you can. It's up to you. Multiplying by 2 on both sides. 16 times 2 is 32. Bring down the x, and that's your answer. Go ahead and try numbers 14, 15, and 16. And really, you could do them all. I just want to point out that in number 15, to be careful. In this problem, we will be multiplying by the reciprocal, okay? And the reciprocal of 3/5 is 5/3. All right, the same thing with number 17. Give those a try. If you're still having some trouble or you're not sure what to do, call Miss Brown. Or raise your hand, rather. All right, welcome back. I want you to just take a couple of minutes, look through my work, and see how you've done. I tried to show as much as I could because I know that we still do not have access to our calculators in class. So even in number 17, I went ahead and showed how I divided 112 by 7. All right. And then I do want to make a note, and I'd like for you to go back in your notes to the beginning, that I have been misspeaking all of this time. In example number 2, when we said G equals 7 is the same as 7 equals G is the same as G equals 7, I said the reflexive property. The reflexive property states that a value is always equal to itself. It is actually the symmetric property that says that we can flip this around and it still has the same value. So if you want to change where you wrote reflexive property to say symmetric property, I don't see it in the fractions section. I do see it one time in example 11. I had to change it to symmetric property. And then in examples 14 and 18, it should also say symmetric. All right, when you're ready, let's look at the watch out section. Here is the watch out section. These are different than what we have done prior to now. And the difference is that, let me choose a different color. The difference is that this x plus 11 is all together in the numerator of our fraction. And we can't do anything with that x plus 11 until it's no longer a part of that fraction. So what we're going to do is still draw our rose line. Whoops, that should be red. Draw our rose line, and then the first priority that we have is to get rid of that fraction. And I'm going to do that by multiplying by 8, because it currently says the quantity x plus 11 is all being divided by 8. So I want to multiply it by 8 on both sides. That cancels. And now when I bring it down, I have x plus 11 equals negative 24. And at this point, it's very easy to go ahead and use my inverse operation. The inverse of plus 11 is minus 11. To cancel that out and get my variable term on its own. All right. So these are the ones to watch out for. Whenever you see a fraction and there's more than one thing in the numerator or the top of it, we need to first get rid of the fraction before we can solve it. I'm going to do number 20 with you, and then I'm going to have you try 21 and 22 on your own. So, number 20, n minus 5, all divided by negative 2. I'm going to multiply both sides by negative 2. Okay, n minus 5 equals positive 14. And now I can do the inverse of minus 5, which will be n equals 19. Go ahead and pause this video and try numbers 21 and 22. All right, go ahead and check your answers for 21 and 22. Again, I applied the symmetric property to both of them in my final step. If you're feeling pretty comfortable, at this point I want you to go ahead and complete the assignment that is posted with this on Google Classroom. If you have any further questions, or if you missed any part of the notes and need to go back, go ahead and either ask Ms. Brown or go back and complete the rest of your notes.